electrochemistry. Our today's topic for video session is Introduction to Electrochemistry, Introduction to half reactions, as well as what you understand by electrode potential. So we all know that chemistry can be divided into different types. Along with it, here one branch of chemistry that we will take in this session. So that is electrochemistry. What is the meaning of electrochemistry? Now actually in physical chemistry we have certain types of properties. So this is one of them and we will study it here. So let's move ahead with it. So electrochemistry is the branch of chemistry which deals with the study of conversion of chemical energy into electrical energy and electrical energy into chemical energy. So it is all about how the conversion of electrical energy is done to chemical energy and chemical energy is done to electrical energy. And this is a very natural process in each and every kind of solution. So that we will study here in this. If we talk about the applications of electrochemistry, so we will find it in different types of electrolysis. We will find it in electrometallurgical field. We can find it in electroplating. We will find it in galvanic cells, or when we use certain type of galvanic cells at that time. We will have here the application in batteries, in fuel cells, etc. So it's possible that whenever we talk about electron, whenever we talk about any kind of energy, and specifically which is electrical energy and chemical energy, at that time electrochemistry comes into picture and we will find its application almost everywhere. So we need to be very clear on this, that how it plays a very important role. Okay, now let's move ahead and let's see that what are actually the half reactions. So we will look here for different types of or different basics of electrochemistry in this session. And first is half reactions. So let us consider the following reaction, which is 2Na plus Cl2 gives 2Na plus 2Cl minus. So this is one reaction. Now it occurs by the transfer of electrons from Na to Cl. Na loses an electron because it contains one higher or one more electron and is said to be oxidized to Na plus ion. At the same time, Cl gains one electron and is reduced to Cl minus ion. So Na will convert itself into Na plus, it will get oxidized, while Cl accepts the electron and becomes Cl minus ion. So reduction of Cl is done now. Such reaction, which is brought about by loss of electron, which is also known as oxidation, and gain of electrons, which is also known as reduction, simultaneously is called an oxidation reduction reaction, or which is also known as the redox reaction in brief. So redox stands for reduction oxidation reaction. So both are combined in redox form. Okay? It may be noted that in the overall redox reaction, no free electrons are generated, because in redox reaction, if one atom loses an electron, then another atom will accept that electron. So in general, they will make at a last a neutral molecule. Okay? So here no free electrons will be generated in half reactions or in redox reactions. Now, the redox reactions can be considered as made up of two different reactions, right? For example, the redox reaction here, what we will have is 2Na plus Cl2 gives Na plus 2Cl minus. Here Na is also of two numbers, okay, fine. So this is first reaction. Now it is composed of two half reactions, as you can see in the image here. One is oxidation, second one is reduction, and both of them combines with each other and forms redox reaction. Okay, so now let's see how oxidation occurs and let's see how reduction occurs. So here, as you can see in the image, 2Na gives 2Na plus 2 electrons. Here our Na atom loses 2 electrons. So when loss of electron is done, it is known as oxidation, which creates positively charged atom or positively charged ion. Why? If we talk about another one, so Cl2 gains 2 electrons. When it gains 2 electrons, it will convert itself into 2Cl minus. Loss of electron is known as reduction. Okay, we will lose, or we are losing the electron. So it is known as reduction. One is oxidation, another one is reduction. Both of them combines with each other and they will form the redox reaction. Okay, so each of the two reactions shows just its oxidation or just the reduction portion of the overall redox reaction. Being half components of the redox reactions, these reactions are called half reactions. Okay, because it contains only half component of the redox reaction, that's why they are known as half reactions. The first half reaction that proceeds by oxidation is often referred to as the oxidation half reaction. The second half reaction that occurs by reduction or by loss of electron, it is known as, or it is referred as, reduction half reaction. Remember it very clearly, oxidation half reaction and our reduction half reaction. So they will move ahead like that. One is known as, both of them are actually the half reactions. Okay. Third one is when the two half reactions are added together, the sum is the net redox reaction. So when the first one, which is known as oxidation half reaction, and the second one, which is known as reduction half reaction, both of them combines with each other and they form net redox reaction. Okay? Now, let's talk about cell potential or EMF. So, in a zinc copper voltaic cell, electrons are released at the anode and it becomes negatively charged. Here we will consider a cell. Okay, so which cell we are taking here is zinc copper voltaic cell. Okay, so in that the point or where actually the electrons are releasing or which are released. So that point becomes negatively charged and it is known as anode. Now, the negative electrode pushes the electrons through the external circuit by electrical repulsions. The copper electrode gets positive charge due to the discharge of Cu plus 2 ions on it. Thus, electrons from the outer circuit are attracted into this particular electron, and the flow of current through the circuit is determined by the push, okay, the push which is of electrons at the anode and attraction of electrons at the cathode. Got it? So what we will have here is the push of the electrons at anode and the attraction of electron at cathode. So these two different types of push are there. These two forces, one at anodic, one at cathode. So these two forces actually constitute the driving force or electrical pressure that sends the electrons through the circuit. Okay, understand it very clearly. These two forces which constitute the driving force or electrical pressure that sends the electrons through the circuit. Okay, so this particular driving force is called the electromotive force, which is abbreviated as EMF, or which is in general known as cell potential. The EMF of cell potential is measured in units of volts, which is capital V, and is also referred to as cell voltage. This is all for this session. Next we will see in our next sessions. Thank you so much everyone.